Hello everyone, once again to this new lecture for continuation part of your essential requirement of indicating instrument. In previous part, we will talking about controlling torque or a controlling force which will allow the particular pointer to move back to its original position or a zero position. Okay, we will talking about two type of controlling force, that is spring control, and second one to be gravity control. In the particularly gravity control, we are talking about how the gravity should be acted by its function of your controlling force, and one of the part should be your spring control, where it act as a natural position to move backward to its original position as a spring enactment. Now in continuation part, uh, today we are talking about damping force. Before proceeding to this particular topic, I have to give some small introductory how the damping force will work in a any indicative instrument. Okay, just for a sake of example, uh, if a pointer is positioned toward the zero position, okay, if it have to be pointing some of the value like 5 ampere, so for providing to the 5 ampere current, it have to be directly not indicating 5 ampere, it have to be move some forward and backward motion, that is called oscillation. In a electromechanical device, it will move backward and forward towards true value for some of the time, and it going that is called oscillations. It will be represented by a time versus uh, amplitude magnitude curve. We will show that if we provided a DC source having some 5 ampere current to be constant, as we ideally assume that the indication in a particularly electromagnetic devices, that when we giving some indication, it will provided the indication at the t equal to 0 instant. It will be indicated thoroughly up to the time we will want it to indicate, up to the force should be there in the particular indication. Now actually, in your electromechanical devices, it will act like this. If the force will be there, deflection force will be there, it does not be act in a t equal to 0 instant. It will be rises by rises toward the true value. It will be somewhat upward position, forward position, sometimes backward position, and will oscillate around the true value, and will be steady as a in the greater than true value or lesser than true value. It should be error. Okay, then will be in the steady state. This particular forward and backward motion of your pointer toward your true value is called oscillation, and it is certainly in case of control system we will call damping. Okay, this particular damping should be reduced by one of the forces or controlling forces we will study in this particular lecture. This particular damping torque provided to reduce this annoying or oscillation forces decreases, will does not be reduced to zero because it does not practically possible. Okay, but will reduce now. And the one of the way of reducing this particular type of damping forces will be like this. As I studied you, the three type of dampings are will there. Under damp function, as I provided you, so the forward and backward motion of a deflection pointer, and one of the ideal position what we wanted, that is called critical damp type system, where the particularly pointer should be in steady state without oscillating. Okay, and third one, that is a over damped response, where it is a slowness. If it will provided the output or it will give the true value without oscillation, but it should be very slow, but the pointer position will be slow. Like if I give you example, the pointer give the true value in a t equal to 5 second, in a 5 second in case of critical damped system. In case of over damped system, the particularly your steady state or a final true value should be provided in t equal to 25 seconds. It will be long time to produce the output of a system. The pointer should be very slow. So we wanted the ideal position, that is a critically damped system, but practically we do not provide it. Why? We will provide this do not as a manufacturer, we does not provide that type of critically damped system, because in some of the times the spring can be loses its particular natural space, and particular electromagnetism should be lose one in the particular time after 1 year 2 years span. Particularly critical damp system will be act as a over damp response. So as a manufacturer or as a electrical measuring instrument person, we does not allow that type of system characteristic. So we always, as a manufacturer, we allow the system to be under damp function. So for a timer span, it will be act as a critical damp system. Okay, it sometime it will be asked in the is in Indian engineer services questions also. Okay, one of the what are the remedies to improve this type of damping function? What will provided in under dam system? What will say it, how we kill the particularly the this damping or oscillation in the system? So three type of system will be used. First is air friction damping, second is full friction damping, and third is your eddy current damping. The one of the basic method behind this air friction damping, that we will the particularly energy, what will the force will be there in case of deflection force, the extra energy we will wanted to be reduced by using the friction forces. What we do, we will provided one of the pointer should be position in particular vacuum of a air chamber. It is connected to one of the piston. Whenever the pointer move forward, when a pointer move forward, this particular pointer will be positioned inward in the air chamber. So when the pointer move forward, the particular piston should be pushed back into the your air chamber. As the friction force should be there, it will be compress the air. The sum of the extra energy will be loose in there. If the pointer will be moved backward in the same way, move backward far away from the true value, then the piston will be allowing itself to be out of the piston. In that direction also we will expand particular air. In that time also we will lose some of the energy in some of in one or two stroke of the piston. The one of the slowness of the particularly piston should be there, and will provided the true value in some of the few oscillation also. Okay, and that is the way how we provided the air friction damping or pneumatic damping, we will also said it. It is a basically a light aluminum frame that is attached to a moving system. As we see the movement of piston in the chamber, and will reduces the oscillation in the circuit. This particular instrument or this type of damping system is used 90% technically all of the instrument like MI instrument and EMMI instrument. One of the next system to be fluid friction damping. It will be same as air friction damping, but perhaps one of the thing that we will replace the air with the fluid. As the fluid has a more friction over the particularly air friction, it will reduce the damping more over the your air friction damping. This type of damping required a light disc which is attached to a simple spindle or a moving system. The motion of a disc basically is a frictional drag on the disc, and when the drag is zero, the disc is stationary and increases the speed of oscillation. And this increment of damping and when in vertical direction reduce in oil immersed system, it will reduce the it will increases the fluid friction damping and reduces the oscillation in system. What are the one of the major disadvantages of this type of fluid friction damping is it will require the regular maintenance and checking of fluid in the system. One of the major application of this type of damping is electrostatic damping methods. Third type of damping, there should be electromagnetic damping. It is one of the major damping that should be used in previous type of energy meters, where some type of damping magnets are should be there. It should be allowed to uh, provided the magnetism toward its aluminum disc across its aluminum disc. As you see, it is an aluminum disc, and should be some north and south pole should be provided in this manner. How it should be work, it should work like this. One of the basic scenario, as we see the aluminum disc is rotated in some of the direction. Okay, whenever some electromagnetic damping is provided in the system, it will provided as a coil is rotated, as conductor is variable, and magnetic field is fixed. Okay, then EMF of current will be produces in this particular in this damping coil. As we saw, this particular damping provided a force that will opposes the motion of this direction. As you see, this is basically a thin disc, is usually of copper or aluminum, mounted on spindle. As you seen previously, also the force exists between the current and magnetic field, provided a opposition force. As I say, also it is basically a opposition force produces due to the induced current due to the damping force. It will oppose the motion of the coil, and this type of instrument is containing the permanent magnet, and it should always be used in PMC meter and electrodynamometer instruments. Thank you so much.